today we are going to fill in that blank. So find that blank spot in your notes. And we're going to fill in that missing information. So you should be finding where we numbered 3 yesterday. Okay, so like Kate, you'll just want to get those notes from yesterday off of Canvas or whatever, like watch that and fill those in, and then we'll go from that point. Okay, so step 3 says if oh, it's like maybe my exasperation made it stop. No, darn it. If variables are on both sides of the equal sign, we are going to have to get them together with the opposite sign. So this opens the door for a couple dilemmas that arise. Okay, step 2 says that if there are like terms, we want to combine them, right? Like terms need to be happening on the same side of the equal sign. Okay, now we're talking about what happens when there's stuff on both sides of the equal sign. Okay, and we cannot just pull like terms together that are sitting on different sides of the equal sign. It then falls into the case that we have to use the same rules we have been doing to like get things moved over to the other side, right? And we do that with inverse operations. So that same idea applies here if we're getting variables together on the opposite side of each equal sign. Now, I do have this little, I don't know, it's gonna go in my t-shirt company, right? Hashtag Team Decimal, fractions are our friends. I'm also gonna have one that's like on one side of the shirt says same side, same sign. And on the other side of the shirt says opposite side, opposite sign. Can't you see how popular my shirt company is going to be? Okay, that if we have something like this. Okay, so we have 4 minus 6x equals 2x plus 5. Right, we have variables on both sides of the equal sign. If those variables on both sides of the equal sign, we cannot just combine them. So we can't just look at these and say, okay, let's put them together. We'll have to get them together with inverse operations and use the opposite sign. Now, some of my students have been taught to always move the smaller one. Some of them have heard always move to the left-hand side. Okay, there isn't a right answer here. Okay, so you might have a preference. I tend to prefer to move whichever one is smaller. Okay, but there is not a right solution here. You can move either x you want to, as long as we realize this. Those are like terms, they both have the variable. And they are on opposite sides of the equal sign, so we have to get them together with the opposite sign. Who has a preference? Who wants to move the negative 6x versus the 2x? Drew, which one do you want to do?
Move the negative 6x.
You want to move the negative 6x? Drew, do you have a reason why you would like to move the negative 6x?
Because then it becomes positive.
Okay, so you want to avoid the negatives. And that is what I hear from a lot of students, to move the smaller one to avoid the negatives. Okay, so how do we undo subtracting 6x? Add 6x. And when I add this 6x, notice I'm writing it in the 2 places that my variable already was. So don't like put your plus 6x over here. Okay, it's just going to make it more messy when you're combining like terms. because our negative 6x and our positive 6x will cancel out. This will give us an 8x. And we could just finish solving from there like normal. Questions on that? Okay, then flip in your notebook to the end of your notes to where we were looking at examples yesterday. Right, we did all the steps. We got to step 6, which was undo multiplication and division. And then we looked at, I think, 2 examples. Right, so after that one, is it 2 examples or did we just do one in here yesterday? Oh yeah, just one because we did the distributing with it. Yeah. My other class is the one that has the question. Okay, so after that example, we are now going to include nope, I lied. Make this a 4 right here. I know. I messed up. I'm sorry. My brain got a step ahead. Okay, so all equations still fall into those steps we talked about yesterday. So we're not just looking at step 3 today. We are inserting step 3 as a possibility. We will still start at the beginning of the list. Step 1 says, if there are parentheses, distribute. So does this problem have parentheses? Yes. Yep. So could we distribute? Yeah. Now, does it have to be the first thing that we do? No. What could be some other options up here that we could do first? Right? We have like terms we could combine over here. We could move this 10 over. Okay, but my students tend to prefer to get both sides simplified first. Okay, so if we distribute, that's going to give us a 3y. What operation do we distribute through? Multiplication. Everything else I just brought straight down. Okay, step 2 says if there are like terms, combine them. So what like terms do we have? Okay, so over here a negative 2y and a 4y. What are these going to be when we combine them? A positive 2y. Those are on the same side of the equal sign. So I want to use the same sign to get them together. Any like terms I can combine over here? Right, so here I can do 24 minus 10, which gives me what? Plus 14. So there's step 2. Step 3 says if there are variables on both sides, get them together using the opposite sign. Do we have variables on both sides of the equal sign? Yes. So which one do we want to move? The 2y? Okay, so 2y, so opposite sign. So how do we undo adding 2y? Subtract 2y. Okay, our next step says large fractions. We don't have any large fractions. And then undo any addition or subtraction. What are we going to get as our final answer? Yes?
So above on the equation it was negative 2y and then it was positive 2 plus 2y.
Yeah.
It was 6 minus 2y.
Right, but right here I put these together and a negative 2y plus 2y is a positive 2y.
Oh, it was 4y. Okay, I didn't put 4y.
You didn't write the 4y down on yours at all.
I changed it to, yeah, I didn't. 4y. 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 4
Okay, now this seems like, okay, yeah, I'm just adding that step in, not necessarily a big deal. But when we add this step in, we open the door for some weird things to start to happen. Like, what happens if we have this equation? Oh my gosh. And then in parentheses, 4w plus 8 equals 4 plus w plus w. Bless you. What are we going to do first? Distribute. What is 1/2 times 4? Because that's the same thing as saying half of 4. I'm sorry if your eyeballs feel like they're going to pop out like mine do. We're almost done with notes. Okay, we have like terms to combine over here, right? What is w plus w? 2w. Now we have variables on both sides. Okay, how do we, well, which do we want to move? Do we want to move 2w or do we want to move 2w? Oh, let's move 2w, right? We don't have much of a choice. So how do we move a positive 2w? Subtract it. I'm going to put it right underneath my other w. What is 2w minus 2w? 0. No w's. Do not make a w appear because it makes you feel uncomfortable that there's not one.
Wait, this is undefined.
Nope. Okay, so does 4 equal 4?
Yes.
Yes. 4 equals 4 is a true statement. If we get a true statement here, anybody say they think they know? Evan, what do you think? That would be a really close idea that a lot of people will use, but we can be even more specific, and I prefer to be a little bit more precise. We are going to say all real numbers. Okay, all real numbers, or all solutions, are the two options that are more specific. Infinitely many solutions is commonly used, and frankly, they use it in state testing as well. Infinitely many solution means that there are so many solutions we can't count them. But class, there are an infinite amount of numbers in between 1 and 2. Okay? This is more precise. This means not only are there so many solutions that we can't count them, this means any number we can think of counts. All real numbers. So any number we can think of counts and works. Nope, we're not packing up yet. We got one last thing we're finishing in this last minute. So what happens then if we have this? What are we going to do first here?
You're gonna combine.
Okay, so combine my y's, which leaves me with what? Is this true?
No.
No. So anybody think they know what they call this? No. No solution. This is a no solution. There are no numbers that work. A true statement means they all work. A false statement means none of them work.